Okay, so I wanted to get back to Brandy because we talked about student comprehension, like conceptual versus production, and we had a really good talk, I thought. But I wanted to do what I promised, which was share some awesome Edtech with you. Edtech for math. So this one is by far my favorite. It's called Explain Everything. So it's just like the name sounds. It lets you make like these miniature Khan Academy videos, and but it's like Khan Academy on steroids, because you can bring in your own video. Like this is Angela Merkel, and she is explaining the
also einer steckt einen an, der natürlich auch nicht, das kann ich immer nur für eine Infektionskette sagen,
explaining the coronavirus epidemic in Germany. And she's saying that if every person right now who is sick in Germany were to infect 1.1 people over the next 6 months, the German health system would be able to cope with that. But if every sick person in Germany were to infect 1.2 people over the next 6 months, they would be out of masks, there would be no available beds, there would be no nurses or doctors that would be free to tend to the needs of these patients or of patients with other standard illnesses. So it's perfect. I mean, you hate to say perfect when you're talking about people dying and pandemics and things like that, but it was a perfect opportunity to link what we were doing last term at Green School with rational functions and exponential growth in this case with something that was actually happening in the real world. And Explain Everything is something that I use during every single class. I use it in every single class, at least to some extent. It allows me to keep a continuity of learning going. And if you miss the class, then I can refer back to the Explain Everything, and I'll talk to you later about Dreamweaver, which is the Edtech tool that I recommend to make a website for your own class, and we can talk about that later. But I put all of my whiteboards on Dreamweaver, and it's easy because it's not actually a whiteboard, is it? I carry my whiteboard around in my hand. It's either my iPad or my iPhone. My whiteboard is with me at all times, and I'm recording. Students are contributing. Students can send things to me in real time that I can display for everyone to see through Explain Everything. And Explain Everything just allows for a very powerful tool. It's not free. I paid $100 for the year. Alyssa said they'd reimburse me for it, but my experience always is that they say they'll reimburse you for everything, and you might end up getting half of it. But I trust Alyssa, so I'm sure she will. Explain Everything is probably the most powerful and most effective math ed tech, except for Desmos. And Desmos I'm going to talk about in a minute. So let me tell you about another one that I'd like to discuss. This was my fear of what ASQ would be like. Please, God. At this point, I'm looking for where that is. We're going to talk about U-Cubed. U-Cubed is an organization founded by Joe Bowler, who is the guru. She is Jesus Christ. She is a professor emeritus at Stanford, where my brother graduated, by the way. And she has single-handedly changed mathematics education to be what it is today. And so I am an apostle of Joe Bowler, and she is very, very important in the world of what we're trying to do. UCubed has it's less of an Edtech thing. It's more like a curriculum inspiration. But what I wanted to talk about with you real quick was this thing called the Week of Inspirational Maths. And the Week of Inspirational Maths is, she said maths because she's English, of course. It's a way to set the tone for the entire year for your classroom. And the reason why I like it is it emphasizes the norms that we want to keep in place, like celebrating the mistakes that get made, like maybe even designated your favorite mistake for the day, and allowing that to be what you talk about, that other people probably make the same mistake, right? So if that one's your favorite mistake, it's no longer a negative thing. It's a contribution that you've just made as a student to everyone else's learning, and you always thank that student. Thank you for forgetting to use a negative sign when you perform that operation, because that is my favorite mistake of the day, because it's something that everybody loves to do, and everyone is prone to do. And I think we should all celebrate that and remember that next time, and thank Angela, because now next time we have a problem like that, we're gonna remember Angela, and we're gonna remember this, and we're not gonna make that that common error. That's just one thing that I kind of like to do. This is an article that Joe Bowler published in the LA Times, which is not a free service, but I have a subscription that I can just share my credentials with you, so you can have it as well. But she published this with Stephen Levitt, and it's about the importance of data, probability, statistics, permutations, combinatorics. All that stuff gets pushed to the side in high school. And why? Why is that not at the forefront of what we teach? This is an article that diminishes Algebra 2 and emphasizes data and statistics. And I couldn't agree more. Algebra 2 will teach you how to fill a whiteboard with complex algebraic algorithms that require one skill that we do want to teach our students, which is attention to precision. But data science, data comes from everywhere. Data is in our lives every day, all the time. And her point here in this article is just that, why is it that Algebra 2 is in every single curriculum, but data and probability get, a week or two if you're lucky? Data and probability work with games. Data and probability work with making money. Data and probability and permutations, and let her say it.
We're at an exciting time, both in terms of the knowledge that's available in the world and the ways the knowledge is being made available. We're also at a time when it seems clear that we need to rethink teaching and learning, incorporating tools and
I can't make it any louder. I hope you can hear it.
Teaching and learning in a 21st century way seems important for schools and for teachers and parents. Over 50 college majors asked for a
Right now she's saying that there are 50 majors at Stanford which require significant class time. I don't remember how many credits she said, but significant number of credits in statistics. It's just like calculus, right? So bang, 50% of freshmen fail calculus 1. That's just true. That's a statistic in the United States. And suddenly, you're not an engineer anymore. Suddenly, you can't be a dentist anymore. Any Bachelor of Science degree requires extreme amount of data and data science. And we don't give it the attention that it deserves. And it's our job to prepare students for that and for the challenges that are coming up, especially the job of the later in high school teachers. If you look at U-Cubed and you click those 3 bars up in the corner, you're gonna get a trove of information. This is no longer Edtech, it's just resource. If you hit that ideas and impact bar, you get special ed advice for math, assessment, number sense, and mathematical freedom is what she calls the idea of being able to think for yourself and to express your understanding of the mathematical content in your own way rather than a prescribed method that must be done. Depth over speed. You see that depth, not speed. We've all heard that before, right? We've all heard that if you just skim over the top of all the curriculum, there's no enduring understanding. There's no lasting knowledge. And if you hit the tasks and more, there's so many great high-level tasks in here. So that means these tasks are going to be low floor, high ceiling tasks. And these tasks are going to give every student a chance to express themselves, and every student a chance to see math as something that they care about and that's important, especially through the lens of data. I am really a huge proponent of data science, and the fact that Joe Bowler is emphasizing data science right now as well is really exciting to me. Okay, next tool, Desmos.com, the most important math edtech tool, period. Nothing even comes close. Desmos is unparalleled. Its lessons, Colin, I'm not picking on you, but you may have never seen Desmos before, having only taught first grade. It's lessons that are ready to go but require you've got to be behind the wheel. You've got to drive it. So it's not canned. It's not like a IXL thing. It's activities that are interactive and engaging. So no longer am I giving kids pieces of graph paper. I'm asking them to land a plane without killing all the passengers on board. And Brandy, here you go. This is a grade 8 activity. You are going to need to, a huge part of your learning targets are going to be about lines. Okay, so you're going to need to have students understand that lines can be represented in multiple ways. They can be represented in graphs, in tables, in equations, multiple kinds of equations, multiple formulas apply, point slope formula, standard form, while the slope intercept form. All these are crucial learning targets that kids in grade 8 are going to be laser focused on. And there's one of these Desmos activities that I'm just going to show you as an example so that you get an idea of how it works when you find one that you like and that works with your lesson for the day. So like I said, land the plane. We're going to talk about that one. But before that, let's talk about turtles, okay? Everybody likes turtles. Let's see, Ninja Turtles. Red would be Raphael, blue would be Leonardo, right? So Leonardo is much faster than Raphael. Leonardo is able to reach the finish line in a significantly faster rate of speed than Raphael is. So we're able to now take what we've noticed and record it in some form that's organized. Okay, you know how much I love soft skills. You know how much I love talking about approaches to learning and about mathematical practices. And one of those most important ones is to be able to use tools and to choose the correct tool to apply to reach the goal that we're trying to achieve. In this case, what turtle is going to win first? And the tool that the student is using now is a table. And the other mathematical practice that we're emphasizing here is we want that multiple representations to be going on. So we are watching an animation of turtles running. We're creating, using a tool of our choosing, a table, attending to precision, making sure that the observations are accurate. And now that we have this data, the data means nothing. Data is a pile of junk. Data is like you poured out your piggy bank on the table and you got a big pile of coins. It means nothing to anybody. But if we can take data and teach students how to turn data into information by organizing it, then we've done something really important. So we've taken data and we've made information. That's a skill, an ability, a learning target that you'll never see written down on a Common Core website or an IB learning target, but it's what we're going to be able to do, and it's what we can do with Desmos. Now look, we've got multiple representations, including a graph. Awesome. Graphs are not going to be brand new to your kids. They've seen graphs before. They've seen the Cartesian plane. They know what X and Y axes are because they've seen them in grade 6. They've seen them in grade 7. So it'll be maybe a quick review. That's fine. It's called ongoing curricular development. Show it to them every single year, but it becomes more and more of a review and less of a revelation, right? So here, what you've got now is 2 different lines that represent 2 different turtles. How about that third turtle? Can we get him in on this graph? That would be the task that I would place for my table teams, okay? And then I give the table teams a moment, and Desmos is set up their stages. The next step leads this way. The table teams would have a chance now to actually to go there with it. So let's see. Purple. Who's that? Donatello, right? Okay. So you got to know your turtles. I mean, I know that I'm much older than you, but they still made Teenage Mutant Ninja Turtle movies and stuff like that after I was a kid. So I'm still holding you accountable to your turtles. What we've got now is sorry, it's my screencasting software. Now we've got that third turtle graphed, and we can say which turtle is the fastest turtle looking only at the graph. And we can say, looking just at the relationships that we've graphed, we can say lane 3 turtle, Donatello. Why? Because it seems that and then I can share that with the class if I would like to, if I'm outgoing and a student that is comfortable, looking for perhaps other students to agree or disagree. Either way, they're responsible for finishing that piece of the Desmos activity, and it comes to me. It comes to my phone, and I've got now a record of everybody's achievements on Thursday, right? So on Thursday, we did turtle time trials, and I can say that Chris was able to represent in multiple ways the turtle time trials and be successful with it. Now, landing a plane is an interesting idea. It's just kind of intriguing. It's engaging. All right. It's much more. It's much more magnetic to our mind than just looking at a graph and at a point slope equation. All right. So I don't have any problem with this plane being at 0, -7, but I do have a problem with that flight path. That flight path means that he is going to miss the runway completely, and I hope he has enough fuel on board to circle back around. So for these exercises on the next 3 screens, your task is to write the equation of a line that safely lands the plane. Okay, so now kids are like, all right, we gotta land this plane. So do we want a smaller slope or a bigger slope? Will that change? Let's try. Okay, well, let's use a slope of 1. Well, slope of 1 got us closer, but it didn't quite reach the flight path that we're looking for. While we still need a smaller slope, let's try half, 1/2. Y equals 1/2 minus 7. That might work. Let's give it a try. Okay, so now we have an equation for a line that will send this plane directly to the airport. A dead stick landing. That's what they call that in the aviation industry, right down the middle of the runway. And we have also got every student's progress recorded in that area. So Desmos also, if you leave behind all those pre-created activities, you can make your own, by the way. You go to the most powerful calculator that you will ever need. This is why we don't need TI-84s. This is why we don't want TI-84s. This is colorful. It's zoomable. It's it's everything that a TI-84 wishes it could be. All right. So I was just teaching rational functions last quarter. Like we were looking at graphs that would have taken, like a lot of time to do by hand. I'm not emphasizing, that's not one of my that's not one of my goals to have students learn to make hyperbola by hand. That's not really important to me. But what is important to me is that those students are able to use a tool, find a tool, attend to the precision required to get the graph done and understand it correctly. They can trace across it, talk about it. Now, like this was the rational, exponential function that we had to graph at one point last quarter, and that's it looks like the side of a rectangle, but when you zoom in, oh well, it's not, is it? It's curved. Well, why is that? Well, because 15 to the negative 1 is 1/15, right? And 15 to the negative 2 is 1/225. So if you have a small region like this where this rocket ship takes off from -2 to 0, everything changes about this graph. That asymptote, no longer that horizontal asymptote at y equals 0. We kind of leave that in the dust, and we start toward a brand new future, which is positive infinity. So very powerful tool. And the last piece of Edtech that I want to show you, because I don't want this video to get too long, is just right from the New York Times. It's a regular feature. New York Times, again, is not a free service, but I have a subscription. I'll just give you my credentials like with the others. I just give them this picture, and it's a great bell ringer. kids will come in and they'll see this and they'll say like, why are all the hamburgers? Oh man, we haven't had lunch yet. I'm already interested. There's bacon and you know, and there's a why is the avocado and the cashew and the kale and hummus all up in the corner up there? And it does seem to form some kind of a linear relationship, but then there are these outliers, this coconut oil and yogurt down to the right, and we're not sure. Again, we're coming from the two primary access points. What do you notice? What do you wonder? What do you already get, or what can you derive from seeing this picture, and what is just not there that you need, that you would like to know, or that you don't have but are looking for? And I erase anything that leads them to realize the actual answer. And this is, of course, a graph that shows the y-axis is the percent of nutrients in a food, and the x-axis is the percent of Americans that think that food is healthy. So interesting, and very unlikely that a kid will guess that, especially in the very short amount of time that I'll give them. I have to be careful, though, because I can spend an entire class on just this one thing, because I love this. This is my favorite new Edtech resource. What's going on in this graph here, this one is mental health of teenagers, and this just blows Asian kids away. Like 50% of teenagers in 2018 were dealing with some form of drug addiction. And that's like, they say things like, what? When they're in high school, they have drug addiction? Where do they, what drugs did they do? Heroin, cocaine, marijuana, LSD, methamphetamine? What? Where do they get it at high school? Who do they buy it from? Their classmates. That one just kind of blows their mind. And so, but it's again, though, it's data organized, and now it's become information. And once data becomes organized into information then can be collected, thought about, shared, and become knowledge. And knowledge can be celebrated, become theorems, become books, become common ground for the improvement of humanity, the saving of the planet, and ultimately the final stage is wisdom. So if we can take kids and allow them to start with data, form information, create knowledge, and leave with wisdom, that's beyond math. That's they like to talk about cross-cutting skills in science. In next generation science standards, they use CCCs, like skills that cut from chemistry to biology to earth and space science, like things that, like gravity, applies to all of these. In math, something like this is not just for math class. If they learn this in math class, they can now go and read Taming of the Shrew and better understand the plot twists and like that kind of ability to take something they've never seen before and apply what they've learned to it is very high on our list of things that we should be proud of if we can achieve. So those are some EdTech resources. I've got a billion more. I'm going to send you some more later. Not today, though. That's enough for today. Thank you for your patience listening through here, and you haven't seen the last of me. Signing off. Have a great day.